The topic we are going to look at conversion of NFA with epsilon to without epsilon. Coming to the first problem, convert the following epsilon NFA to NFA without epsilon. In the first step, find the epsilon closure for the given transition diagram. How to find the epsilon closure? By looking at the transition diagram, in which state the epsilon closure starts and ends. There are 3 states in this diagram and we need to find the epsilon closure for each state separately. Coming to the first step, as per the theorem, del cap of q naught comma epsilon equal to epsilon closure of q naught. We need to find out epsilon closure of q naught. Look at the transition diagram. Q naught, seeing a symbol epsilon, it reaches to q1. Again q1, looking a symbol epsilon, it reaches to q2. Here in this diagram, epsilon transition starting from q naught, q1, q2. Here you write q naught, q1, q2. Next, del cap of q1 comma epsilon equal to epsilon closure of q1. So we need to find out epsilon closure of q1. Take q1 and seeing a symbol epsilon, it reaches to q2. So you should write q1 and q2, q1 comma q2. Next state, del cap of q2 comma epsilon equal to epsilon closure of q2. Here in this transition diagram, there is no epsilon transition. So you just write q2 here because it starts from q2. I just write it here q2. Coming to the second step, find the transition on each state for each element. In this transition diagram, we have 3 states q0, q1, q2. Take the initial state q0 and apply all the inputs 0, 1, 2. And next state q1 and apply the input 0, 1, 2. And last state is q2 and apply the input 0, 1, 2. Here first initial state q0 and apply all the inputs 0, 1, 2. In the first subdivision, del cap of q0 comma 0 equal to epsilon closure of, apply an extended function del cap of q0 comma epsilon comma 0. Here q0 comma epsilon, which means we already found the epsilon closure of q0. Look at the first step, epsilon closure of q0 is q0, q1, q2. Here you write q0, q1, q2. So del of q0, q1, comma q2, comma 0. And next step, del of q0, comma 0 union q1, del of q1, comma 0 union del of q2, comma 0. Here q0, comma 0. Look at the transition diagram, q0, comma 0. So q0, 0 goes to q0 itself. Here you write q0. Next one, union of del of q1, 0. Look at the transition diagram, q1, 0, there is no transition here. Just put null symbol. Union of, next one, union of del of q2, comma 0. Look at the transition diagram. Here q2, comma 0, there is no transition. Here you put null. When you apply the union operation here, q0 union null, you will get q0. So epsilon closure of q0, we already found in the first step, epsilon closure of q0 is q0, q1, q2. Here you write q0, q1, q2. And next input, del cap of q0, comma 1 equal to epsilon closure of, do the extended function del cap of q0, comma epsilon, comma 1. Next, epsilon closure of del of, here q0, comma epsilon. So epsilon closure of q0 is q0, q1, q2. Here you write q0, q1, q2 and input going to be 1. Next step, epsilon closure of del of q0, 1 union del of q1, 1 union del of q2, comma 1. q0, 1. Look at the transition diagram, q0, 1. There is no transition. Here you put null symbol. Union del of q1, 1. q1 on seeing input symbol 1, it reaches to q1. Here you mentioned q1 union del of q2, comma 1. Look at the transition diagram, q2, 1, there is no transition. Here you put null symbol. Then apply the union operation, null union q1 union null. Here you will get q1. So epsilon closure of q1, Look at the first step. Epsilon closure of Q1 is Q1 comma Q2. Here you write Q1 comma Q2 and last input is 2. So del cap of Q0 comma 2 epsilon equal to epsilon closure of apply an extended function del cap of Q0 comma epsilon comma 2. Next step epsilon closure of here Q0 comma epsilon. So epsilon closure of Q0 is Q0 Q1 Q2. Here you write Q0 Q1 Q2 comma 2. So input is 2 here. Next step epsilon closure of del of Q0 comma 2 union del of Q1 comma 2 union del of Q2 comma 2. Here Q0 2, look at the transition diagram. Q0 2, there is no transition. So put null symbol. Q1 2, look at this transition diagram. Q1 2, there is no transition. Here you put null symbol. Union Q2 2, see the transition diagram. Q2 on seeing a symbol 2, it reached to Q2 itself. Here you mention Q2. When you apply the union operation, here you will get null union Q2 here. So epsilon closure of Q2 we already found in the first step. Epsilon closure of Q2 is Q2. Here you write Q2. So we done Q0 part and next state is Q1 and apply all the inputs 0, 1, 2. Similarly, next state Q2. Here del cap of Q1 comma 0 equal to epsilon closure of do the extended function del cap of Q1 comma epsilon and input is 0. Here Q1 epsilon which means epsilon closure of Q1. Look at the first step. Epsilon closure of Q1 is Q1 comma Q2. Here you write Q1 comma Q2 and input going to be 0. Next step epsilon closure of del of Q1 comma 0 union del of Q2 comma 0. So Q1 del of Q1 comma 0. See the transition diagram. Q1 0, there is no transition here. Here you put null symbol. Union del of Q2 comma 0. Here Q2 0, there is no transition. Here you put null symbol. When you apply the union operation, you will get null. So epsilon closure of null is null. And next input is 1. So Q1 1 equal to epsilon closure of del cap of Q1 comma epsilon comma 1. Here I applied extended function. So epsilon closure of Q1 epsilon. See the first step. Epsilon closure of Q1 is Q1 comma Q2. Here del of Q1 comma Q2 and input 1. Next step del of Q1 comma 1 union del of Q2 comma 1. Q1 1. See the transition diagram. Q1 1. Q1 on seeing a symbol 1 it reached to Q1 itself. Here you write Q1 union Q2 1. Del of Q2 1. Look at the transition diagram. Q2 1 there is no transition. Here you write null symbol. When you do the union operation, you will get Q1. So epsilon closure of Q1. See the first step. Epsilon closure of Q1 is Q1 comma Q2. Here you write Q1 comma Q2. Next input is 2. So del cap of Q1 comma 2 equal to epsilon closure of del cap of Q1 comma epsilon comma 2. Here Q1 epsilon. What is Q1 epsilon? Here look at the first step. Epsilon closure of Q1 comma Q2. Here I mentioned epsilon closure of del of Q1 comma Q2 and input going to be 2. Next step del of Q1 comma 2 union del of Q2 comma 2. Here Q1 2. Look at the transition diagram. Here Q1 2 there is no transition. Just write null. Here null union of del of Q2 comma 2. So Q2 on seeing a input symbol 2 it reached to Q2 itself. Here you write Q2. Then do the union operation, you will get Q2. Epsilon closure of Q2. What is epsilon closure of Q2? Here epsilon closure of Q2 is Q2. Here you mention Q2. And last state is Q2 and apply all the inputs. q2 0 equal to epsilon closure of, apply an extended function del of del cap of q2 comma epsilon comma 0. Here epsilon closure of q2 epsilon. So, q2 epsilon means epsilon closure of q2. Look at the first step, epsilon closure of q2 is q2. Here epsilon closure of q2 is q2 comma input is 0. Look at the transition diagram, q2 0, q2 0, here there is no transition, just put null symbol. Next one, q2 1 equal to epsilon closure of, do the extended function del of del cap of q2 comma epsilon comma 1. Here epsilon closure of del of q2 epsilon. So, q2 epsilon means epsilon closure of q2, q2 here. Here you mention q2 comma input is 1, q2 1. Look at the transition diagram, q2 1 is, there is no transition. Here you put null symbol. Next input is 2. So, q2 comma 2 equal to epsilon closure of, do the extended function del of del cap of q2 comma epsilon comma input 2, q2 epsilon. So, epsilon closure of q2 is q2. So, q2 comma input going to be 2. So, here q2 2, del of q2 2 means, look at the transition diagram, q2 on seeing input symbol 2, it reached to q2 itself. Just here you write q2, epsilon closure of q2. We already found in the first step, epsilon closure of q2 is q2. So, here you write q2. Next, third step. In the third step, finally in this third step, you have to put the transition table and a transition diagram. There are 3 states in the transition diagram, q0, q1 and q2. Here in this transition diagram, q0 is the starting state and q2 is the final state. But when we move from NFA to the NFA without epsilon transition diagram, here the final state changes, because in the given original diagram, wherever the epsilon transition starts and ends, that is your final state. In this transition diagram, epsilon transition starting from q0 and ending at q2. So, all states in this are final states. Here I am writing inputs are going to be 0, 1, 2. So, here starting state q0, q1, q2. Here starting state is q0. As per the diagram, q2 is our final state. Wherever the epsilon transition starts and ends in the original transition diagram, that is your final state. In this transition diagram, epsilon transition starting from q0 and ending at q2. So, all states in this are final state. Here I mentioned starting state q0 and final state is q0 and q1 is also final state, q2 final state. Input are going to be 0, 1, 2. So, q0 0, look at the second step, q0 0, q0 q1 q2, and next one q0 1 is q1 q2, q0 2 is q2. In this table, q0 0 is q0 q1 q2, q0 1 is q1 q2, q0 2 is q2. Next state q1 and apply all the inputs 0, 1, 2. See the second step, q1 0 null. Next one, q1 1 is q1 q2, q1 2 is q2. In this table, q1 0 is null, q1 1 is q1 comma q2, q1 2 is q2. Next state q2 and apply all the inputs 0, 0, 1, 2. Look at the second step, q2 0 null, q2 1 null, q2 2 is q2. Here I am writing q2 0 is null, q2 1 is null, q2 2 is 2. Finally, draw the transition diagram using the transition table, q0 0. So, totally we are having 3 states, q0, q1, q2. Here q0, q1, q2, starting state is q0 and final states are q0, q1, q2. Here I mention the double circle. So, starting state q0 and final state going to be q0. Here final state is q1, one more final state is q2. So q naught 0 goes to q naught q1 q2. Q naught 0 goes to q naught q1 and next one q2. Q naught 1 goes to q1 q2. Q naught 1 goes to q1 and q2. Q naught 1 goes to q2. Q naught 2 goes to q2. Q naught 2 goes to q2. Next second state is q1 0 null, leave it. Q1 1 goes to q1 q2. Q1 1 goes to q1 itself and q1 1 goes to q2. Q1 2 goes to q2. So q1 2 reach to q2. Last state q2 0 null, leave it. Q2 1 null, leave it. Q2 2 goes to q2 itself. Q2 seeing a symbol 2, it reach to q2 itself. I am giving you a problem. Solve this problem. In the given problem, when you convert NFA with epsilon to without epsilon, you will mention in the comment box what is your starting state and final state. I think you understand this problem well. Thank you.